Hello, my name is Mikhail Polivny, and I'll be providing an update on the modifications that have been made to the mechanical and structures subsystem of the drone since last semester. First, I will cover updates to the airframe. So the composite shell design of the airframe has been improved. The new composite shell design is composed of 4 layers of plain weave fiberglass fabric with an epoxy matrix providing a shell thickness of 1 millimeter. For the leading edges of the wings, the nose, and the belly of the airframe, the shell now includes carbon nanotubes and a layer of Kevlar fabric in addition to the fiberglass. This improvement is based on areas of stress concentration that were identified from FEA analysis. So 3 separate studies were done to simulate situations the airframe will most likely encounter, which includes hard landings on the nose and wings, as well as the forces experienced from launching. And with a 10G loading, the minimum factor of safety in these studies was just over 8. Next, I will cover improvements made to the launcher. So the launcher has been fitted with 4 new elastic bands after conducting an airfoil analysis on the airframe and determining a stall velocity for the drone of 9 meters per second. The new elastic bands provide the necessary force to launch the drone to a takeoff velocity of 13 meters per second, ensuring the drone makes it safely into flight. The guide mount of the launcher has also been updated. The guide mount, which includes the bearing system, is the moving portion of the launcher where the drone is placed. The body of the new guide mount is made from a single piece of 5-inch square aluminum tubing, and the bearing system now consists of 16 bearings, which is twice the amount of the previous design. So this provides added stability and prevents any unwanted movement during launching. The launcher has also been fitted with a quick release system. So to explain this, a shackle with a quick release pin is now attached to the end of the winch cable. This shackle attaches to the rear of the launcher drone mount. The winch is then used to pull the drone mount to the rear of the launcher, which places tension on the elastic bands. To then fire the launcher, the user simply has to pull on a rope attached to the quick release pin. So this allows for the user to remain at a safe distance when operating the launcher and greatly reduces the chance of injury to the user in the event of a malfunction. So these updates help to increase the survivability of the drone and ensure it is adaptable to a wide variety of environments. Thank you.
Hello everyone, my name is Tyler Bagnall and I'm going to briefly explain and provide an update to the electrical components of our UAV's electrical subsystem that have been conducted over the past year. To start on the changes that have been made during 2020, first is the update done to the GPS module due to its struggle with finding the appropriate amount of satellites for flight and elevation data. This was resolved by hard calibrating the system using Mission Planner and manually inputting drone data to initially find the drone's current location for future use. What this did was provide a more accurate elevation and flight data for our drone. Next, a new transmitter and receiver for FPV camera were bought to provide up-to-date technology for faster and clearer transmission. The transmitter and receiver combination operates at a 5.8 GHz frequency range, which allows for a much higher video quality and faster transmission of data. And lastly, we updated the computer for use with our Mission Planner software. What this does, it provides power to various electronics while we are away from any wall sockets while out in the field. It's also versatile to use to allow for closer contact during the UAV's takeoff and landing, as well as operations closer to the UAV flight path for easy open airspace communications. It also runs the newest and most updated Mission Planner software for faster and more accurate communication inputs between the user and the UAV. So, as for what we've conducted so far in 2021, we have verification of the flight control system, as well as in-flight reprogramming by use of the Mission Planner software UAV simulation tool. What this allows us to do is create and upload a flight path mission to the drone for simulation purposes to ensure proper communication between the ground station and UAV, as well as verifying the in-flight reprogramming capabilities. We have the intention of updating the camera to a Mapier Survey 3 surveillance camera. This will allow for the continued FPV capabilities with an added benefit for in-flight photo data gathering that can be stored within the drone's onboard SD storage card and can be used for surveying of the land below via HD photo imagery post-flight. Lastly, multitude of tests have been conducted throughout the drone's electrical subsystem, from verifying power input to all the electronics, verification of telemetry and transmission functionality with the live video quality test, and finally, the autonomous and remote control functionality verification tests via the Mission Planner software simulator. The progress that has been made over the last year will help us with achieving the project goal of autonomous flight with high quality video first-person viewing capabilities for precision in-flight surveying. Thank you.